How can a line be partitioned? We're going to find a point on a directed line segment between two given points that partitions, meaning we're going to divide it, the segment into a given ratio. Remember, a ratio is just comparing two different groups. So, what point would separate x sub 1 and x sub 2 in a ratio of 1 to 3 from the first point, x sub 1? Well, first of all, we're talking about equal parts here. So 1 to 3, how many total parts are there going to be? We're going to add 1 plus 3. We're going to divide this whole length into 4 equal parts. So the question becomes, what is the whole length? How do you find the distance between 2 points? Well, when they're horizontal or vertical, we can just subtract them. So to find this distance from x sub 2 to x sub 1, we're going to say 9 minus 1, and there's 8 total spaces. So the whole distance is 8, and we want to break it up into 4 parts. What operation takes a distance and breaks it into even segments? Well, that's division. So we're going to divide 8 by 4. So let's talk about how this would apply to our partitioning formula and how we could extend this basic idea of taking the distance, adding the ratio to get the total number of parts, and then changing those amounts. So the first thing we did was we found the distance between the 2 points. And we did that by subtracting our 2 points. That gave us the distance. Next, we multiplied the difference by the fraction. Well, we knew we were going to find 1 part out of the 4, that total ratio 1 over 1 plus 3. That's the same as saying A to B, our ratio. We're finding A, the first part of the ratio, divided by the total amount of parts. Remember, the ratio of the 2 parts of the segment is 1 to 3. That's where that 1 and 3 came from. Last but not least, we had to add that back to our original point. So our distance here was 9 minus 1 gave us 8. And then if we do 1 over, we're going to multiply it by 1 over 4. Remember, 1 plus 3 gave us that 4. That becomes 8 over 4. What is 8 over 4? Well, we know that that amount is 2, but we have to add that back to our original point. Well, here's our original point. If we add 2 to it, we find the point C that partitions that in a 1 to 3 ratio. You can see it even easier if you divide these. Remember, each section is worth 2 points. So we have 1, 2, 3, 4 parts in this whole segment, but we were looking for the 1 part to the 3. How does this generalize? How does this relate to your formula sheet formula? Well, what was the first thing that we did? We subtracted to find the distance along that line. We subtracted x sub 2 minus x sub 1. We found the difference between those 2 points. Then we took our ratio and we added a and b to find the total, and we put the first number in our ratio on top because we wanted to find 1 out of those 4 total pieces. Last but not least, after we found the difference and we multiplied that by the ratio, we added it back to our starting point. Now that was just for a horizontal line. That's why we were dealing with x's. The same process can be repeated with the y's. So you would still find the vertical distance by subtracting your y values. You would use the exact same ratio as you did for your x because we're still working with that 1 to 3 ratio. And then you're going to add it back to the y value, which was part of your starting point. So let's look at an example here. Find the point that partitions the segment AD at 2, 5 to 8, 14 at a ratio of 1 to 2. First, we're going to plot the point 2, 5. Come right 2, up 5. This is point A. Point D is 8, 14. So here is 5, 6, 7, 8, 10, 11, 12, 13, 14. There's D. So we're looking for a point along this line segment that divides it in a 1 to 2 ratio. First of all, Let's write out our coordinate points. We have 2, 5, and we have 8, 14. I want to color code. This is my X, and we'll do our Y's in green. Let's start with our horizontal difference first. So we're going to subtract 14 minus, let's start with our Y's first. We're going to start with subtracting 8 minus 2, that's the difference, and we're going to multiply it by the first number in our ratio, A, 1 over A plus B. Well, if we add 1 plus 2, we have a total of 3 parts. So we're going to multiply that, and then we're going to have to add back on the original value from our X, which was point A, which was 2. So what is 8 minus 2? Well, you say, that's easy. That's 6 times a third. So if we do 6 times 1 and divide it by 3, we get 2. And we add that original X value, and we get 4. All right, so now let's look at our Y's. Let's start by taking the difference. We have 14 minus 5. And then we're going to have to multiply it again by the same ratio. A was 1 over the total number of parts, 3, plus the original Y value, which was 5, going back to point A. This was our original right here. All right, so 14 minus 5 is 9 times 1/3. So 9 times 1 is 9, divided by 3 is still 3, plus that initial value that we started with the Y at 5, so we get 8. Which means that we have partitioned this in a 1-to-2 ratio. So if we go to the point 4, 8, this is the point that segments that ratio in a 1-to-2. There's 2 congruent parts on the right side of that point and 1 on the left